This video is a short summary on the methods that you have to solve systems of linear equations. Remember that a linear equation is an equation where you have two variables, and none of those variables have powers in it. You just have the x and the y. And a system of linear equations is where you have two or more equations. We're normally going to use now two. Okay, so which methods you have to solve systems of linear equations in two variables? Okay, in the British system you normally use there's three methods: graph, substitution, and elimination. And I want you to have a short video explaining the steps of each method, and then you will have other videos on the channel and on our e-learning system for you to see examples on each. Okay, so the graph method, what do you have to do? First, you have to plot the first equation, or the first line. Then you have to plot on the graph the second equation or line. For both plots, you need to create a table of values. And I recommend at least 3 values of x and y. Okay? You have 2 points, you get a straight line through 2 points, but use at least a third value to check that it's correct, just in case you've made a mistake on one of them. Okay? So plot the first equation on the graph, plot the second equation, and the intersection, the point of intersection, is the solution. You draw the first line, draw the second line, and the point of intersection, the x and the y for that point, is the solution of the system of linear equations. If there's no point of intersection, if they're parallel, then there's no solution, but you normally won't get that. Okay? So, this is the only method that you have to draw. It's graphical. The other two, you have to be able to solve through mathematical methods. Okay, so substitution and elimination. What's substitution? Okay, so what you have to do is you solve one of the equations for one variable. Which equation and which variable? The easiest one. For example, if you have on one of the equations the x without a coefficient, use that one. If not, use the easiest one or the one you prefer most. So you solve one of the equations for one variable, and that should leave you something like x equals 5y minus 3 divided by 2, for example. Okay? Then you substitute that solution on the second equation. So for example, if you had x equals, you get the value of x, this 5y minus 3 divided by 2, and you substituted where it says x on the second equation. Then if you do the second step, you obtain on the second equation just one variable, because where you had x, you put 5y minus 3 divided by 2, for example. So you will only have y's, or x, whatever you've done. And then you solve the second equation. That should give you value. That value, you substitute it on the first step. You can do it on the first step or on any of the equations with the two values, but the first step you already have x equals something, so if you substitute it, that will give you a value. And that will give you both values for both variables. Okay, that's easy. Elimination. Elimination normally is a bit more complicated, but you need to know it. What you need to create is an equivalent system where one of the variables has the same coefficient on both equations. For example, if you had 5x plus blah 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 equals blah blah blah, and then you had 10x equals plus blah 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 equals blah blah blah. So you have two equations, one has 5x and the other one has 10x. You have to multiply the first equation on both sides by 2, so you have 10x in both equations. Okay? So create an equivalent system where one variable has the same coefficient. You have to subtract both equations. As you have the same coefficient in both equations, when you subtract both equations, one of the variables will disappear. So you solve for the remaining variable. And then you use that solution on any of the equations. Okay? So the first step is the most difficult. You have to create an equivalent system. How do you create an equivalent system? Remember, when you multiply or divide both equations, both sides of the equation doesn't change. Okay? So multiply both sides of the equation to obtain the same coefficient in one of the equations as you have on the other one on the variable that you've chosen. How do you choose it? Well, use an easy one. Okay? If you're lucky and you have the system of equations where one of the variables has no coefficient, you can just, or the same coefficient, you can jump the first step and go to the other one and just subtract them. When I say subtract, it's because you have to, you want to eliminate that variable. Some teachers teach the method by saying create an equivalent system and then change this whole sign of one of the equations and then you add them. Well, adding two equations where you've changed the sign is like subtracting one of them. Okay, so that's the same. So this is a summary of the methods to solve the systems of linear equations into variables. Now check the other videos to see each example, each method, how to do it, and make sure you can work with any of them. Okay?